Let's do IXL 8th grade T11. Go to Learning. Make sure you're on Math. Then go down to 8th grade. And then down to T11, volume of cones. All right, let's just review over here on page 12 of the reference pages. Over here in volume, I have cones in the pyramid section, even though a cone is not technically a pyramid because the sides of a pyramid are all supposed to be triangles. So a cone does not have triangular sides. But I still have it in the pyramid section because the way that you calculate the volume is the same as for any pyramid. You just find the area of the base and you multiply it by the height and then you divide it by 3. So remember, I talked about this in the video on the volume of pyramids. If you compare this formula with this formula over here, you can see that really this is telling us that the volume of a pyramid is 1/3 as much as the volume of a prism with the same base and height. In other words, let's look at this cylinder over here and this cone. Let's say that the area of the base was the same for both of them. So let's say that the size of this circle over here is exactly the same as the size of this circle over here, and the height over here is the same as the height here. If you were to pour water into this and pour water into this, which one of these objects would hold the most water? The answer is that the cylinder would be able to hold more water than the cone. And the question is, how much more? Does the pyramid or does the cone only hold half as much as the cylinder? Does the cone hold 1/3 as much as the cylinder? And it turns out that the cone would hold exactly 1/3 as much water as a cylinder that had the exact same base and height as that cone. So when we want to find the volume of a cone, or any pyramid for that matter, we start off by using the same formula as for finding the volume of a prism, which is just we find the area of the base and we multiply that by the height. But then what we're going to do for a pyramid is we're going to take that and divide it by 3. So in other words, we start off by finding the volume of a prism that has the same base and height as the pyramid that we're interested in, but then taking that volume and dividing it by 3 to find the volume of the pyramid, because again, the volume of a pyramid is only 1/3 as much as the volume of a prism with the same base and height. So with that in mind, let's go over to IXL and do some of these problems. What is the volume of this cone? Use pi equals or is approximately equal to 3.14 and round your answer to the nearest hundredth. Okay, so what was our formula for finding the volume of a pyramid or a cone? The formula is that the volume is the area of the base times the height divided by 3. Now, in the last video that I did on pyramids, we were looking at pyramids with rectangular bases. or pyramids with triangular bases. That is, pyramids where the base was a rectangle or a triangle. Now the base is a circle. So we have to remember how to find the area of a circle. So let's go back to the reference pages and just look up here, and we have it right here. The area of a circle is pi times the radius squared, or pi r squared, where r is the radius. So let's put that in over here. For the area, we have pi r squared, and we're going to multiply that by the height, which is 17. And we're going to divide all of that by 3. Now, actually, I'm not done plugging in here because I still need to know what the radius is. So IXL was kind enough to tell us what the radius is. It said that the radius, so from here to here, remember the radius should only be going halfway. So from the middle of the circle to the outside. IXL is telling us that that is 7 centimeters. So let's just plug a 7 in here for the radius. So now we're going to get the volume is equal to pi times 7 to the second power, don't forget the exponent, times 17 over 3. And actually, you know what? Let's also plug in for pi. We're going to use 3.14. So 3.14, there it is. Okay? And now we can just plug all this into a calculator to make it easier. So we have 3.14 times 7 times another 7, because remember, that 7 is being raised to the second power. That means it's 7 times 7 times 17, which was the height of the cone, divided by 3. And then we're going to have to round to the nearest hundredth. So remember, the hundredths place is 2 decimal places after the decimal point. So that's right over here. And then, so this is going to be my rounding digit, and the next one over is going to be my decision digit. So if my decision digit is a 0, 1, 2, 3, or 4, then the rounding digit stays the same. If the decision digit is a 5, 6, 7, 8, or 9, then the rounding digit gets bumped up by 1. In other words, we're asking ourselves, is this number closer to this, or is it closer to this? Is 871.8733333333 blah blah blah, is that closer to the number 871.88, or is it closer to the number 871.87? And the way that we figure that out is by looking at the next digit. If the next digit is a 0, 1, 2, 3, or 4, then it means that this number is actually closer to this. If the next digit is a 6, 7, 8, or 9, then it means that this number is actually closer to this. Now, if the next digit is a 5, then technically that would mean that this number is exactly halfway between these two numbers. But still, it's people tend to round up in that case. So the rule that most people follow for 5 is just to round it up, just like 6, 7, 8, or 9. So anyway, for this problem, we're going to round down here, and that would be 871.87. What did I do? 871. Oh, so, yeah. Oh, I typed it in as 817 by mistake instead of 871. All right, so I just made a little careless error when I typed it in. That's okay. So I'll just remind you, since we're here, if you make a mistake on IXL, please scroll down. Don't just hit got it right away. Scroll down and read the explanation that IXL gives you so you can hopefully get the next question right. So I actually did all of the work correctly here. I just accidentally typed it in, the numbers in the wrong order. So I'm going to move on. The next question is a word problem. A cone has a height of 20 yards and a radius of 12 yards. What is its volume? So let's draw a little picture here. The height is 20 yards. The radius is 12 yards. What is the volume? Again, volume is equal to the area for any pyramid, including a cone. I'm including cones under the category of pyramids, even though they're not technically pyramids. The volume is equal to the area of the base times the height divided by 3. So the area of a circle is pi r squared, and the radius here is 12. Well, I'll just write pi r squared first, and then... So far all I did was I replaced a with pi r squared. Now let's go ahead and plug all the numbers in. So we're going to use 3.14 for pi. For the radius, we're going to use 12. And then we're going to square that. Don't forget to put the exponent of 2 there. Multiplied by the height, which is 20, and then divide that all by 3. And that looks like a lot, but it's going to, we'll just use the calculator, and it's very easy. So 3.14 times 12 times another 12. Remember, that's what that exponent of 2 means. Times 20 divided by 3 equals... Okay, here we do not have to round because our answer is only going up to the 10th place. And the question was asking us to round to the nearest hundredth. Our answer is not even going up to the hundredth place. So we're not going to have to round here. We're just going to type all of that in. 3014.4. I hope I remembered that correctly. Okay. All right, what is the volume here? Okay, it's giving me another problem where I have to find the volume. We already did 2 like that. So I'm going to move on to the next level. Isn't that the exact same question that it just gave me? I'm going to move on to the next level. Okay, so this one is slightly different. See if you can spot where the difference is. So the only difference here is that this dotted line over here is going, this dotted line over here is going all the way across the circle. So that means that this 16 millimeters is the diameter of the circle, not the radius. Remember, let's go over here to Frydman math again. Where are circles? I forgot where circles are. I think they're on page 14. No, I don't remember. Let's go to, where are circles? Page 13. I was close. Okay, so remember, the radius of a circle is only halfway across. So it's starting from the center and then going out to the exterior of the circle. The diameter of a circle is all the way across. So IXL here is giving us the diameter, not the radius. The radius would be half of this. So if we know that the diameter is 16 millimeters, then we're just going to do 16, we're just going to do 16 divided by 2 is 8. So I know that the radius from here to here is actually 8 millimeters. So that's the only thing that's different in this problem. The rest is exactly the same. So we're going to have the volume is equal to pi r squared. So let's just write 3.14 for pi times r squared. The radius would be 8, so 8 squared, times the height, which also happens to be 8. All of that divided by 3. So let's plug that into the calculator. We have 3.14 times 8 times another 8 times another 8. So 2 of the 8s were from the 8 to the second power. Then the other 8 was from this 8 over here. And then divide all of that by 3. And we're going to have to round again. So we want to round to the nearest hundredth. So the 9 is in the hundredths place. Remember, the hundredths place is 2 spaces after the decimal point. So 9 is our rounding digit. 3 would then be our decision digit. So remember, if the decision digit is a 0, 1, 2, 3, or 4, then the rounding digit stays the same. If the decision digit is a 5, 6, 7, 8, or 9, then the rounding digit gets bumped up by 1. But here it's a 3, so this is going to stay the same. So our answer is going to be 535.89. Let's see if I can put that in correctly. 535.89 cubic millimeters, because we have millimeters times another millimeters times another millimeters. So that's going to give us cubic millimeters, which is to say millimeters to the third power. Submit, and there we go. So here we have another question asking us for the volume. So I'm going to skip. Oh, no. I'm sorry. Oh my goodness. No, I'm sorry. This one is asking us for the radius. So good. I'm not going to skip this one. How can we find the radius of a cone if we know what the volume is? In all of the other problems, we knew what the radius was and we knew what the height was, and we had to find the volume. In this problem, we know what the volume is and we know what the height is also, and we have to find the radius. Now, how do we do that? The answer is we're going to start with the same formula that we've been using. Volume equals the area of the base times the height divided by 3. I'm just going to put in pi r squared for the area of the base, because I know that the base is a circle. We talked about that already. Times the height divided by 3. So now let's plug in the numbers that we know. We know that the volume is 1,000. Here it is. The volume of the cone is 1,205.76 cubic feet. I'm not going to worry about putting the units into my formula, because if I put the units in, it's going to look very cluttered. So I'm just going to leave the units out. That's equal to, I'm just going to replace the pi with 3.14 times the radius squared times the height. The height is 18, so times 18 divided by 3. All right. Now let's solve this equation. So we're going to begin by multiplying. There's more than one way that I can do this. I'm just going to take all of these numbers and do them individually. Yeah, that may not be the fastest way to answer it, but I think it's maybe the easiest way to do it conceptually. So we're going to multiply both sides by 3 to cancel this 3 over here. So now we have 3.14 times r squared times 18 equals, I'm going to use the calculator and say 3 times 1205.76 equals 3617.28. 3617.28. Okay, what can I do now? I can divide, well, yeah, I could multiply this and this together. So you could do, actually, okay, you know what? I will do that. 3.14 times 18 is 56.52. So we have 3617.28 equals 56.52 r squared. I hope I copied that correctly. Was it 56.52? Yeah. So then what I can do to get rid of this 56.52, I'm going to divide both sides by 56.52. So now we have, on the right side, we still have r squared. I'm running out of space, so I'm going to put all of this over here. On the right side, we still have r squared. And on the left side, we have to do 3617.28 divided by 56.52, and that'll give us 64. Oh. Okay. Now, we did not figure out what the radius is yet. We figured out that the radius squared is equal to 64. But we didn't figure out the radius. So what this means is, remember, when we raise something to the second power, that means we're multiplying it by itself. So what this is telling us is that some number multiplied by itself is equal to 64. So what is that number? What number, if we multiply it with itself, gives us 64? How about 5? Is 5 times 5 equal to 64? No. How about 10? Is 10 times 10 equal to 64? No. You probably know the answer. The answer is 8. 8 times 8 is equal to 64. So R must be equal to 8 because R squared is equal to 64. Or another way of just doing that symbolically is to say that we'll take the square root of both sides. So when we take the square root of something, these cancel over here. And the square root of 64 means what number multiplied by itself is 64? And that answer is 8. If you want to know how to do that in the calculator, there should be a square root symbol on most calculators. Yeah, here it is right over here. So if I type in 64 and then I hit this button, it'll give me 8. Right? So that's that. So that means that the radius of this cone is equal to 8. Type that in here. And there we go. All right, let's do one more question where it's asking me for the radius. So again, I'm going to start out with the formula volume is equal to the area of the base, which is pi r squared because the base is a circle, times the height divided by 3. Now let's just plug in the numbers that we know. We know that the volume is 113.04. We know that we're going to use 3.14 for pi. We don't know what the radius is, so we're going to have to keep that like that. We're going to multiply by the height, which is 12, and divide all of that by 3. So we have 113.04 well, okay. I went too far. So now let's solve this equation for r. Now, one thing that I could do here actually is you could say that 12 divided by 3 is 4. So you could rewrite this as 3.14 r squared times 4 without the 3 anymore because we just divided it into the 12. But I'm not going to do that because in most cases you're probably not going to be able to do that. So I'm just going to do it sort of the long way and multiply both sides by 3 to show you what you would normally do if you can't use any shortcuts. You would multiply both sides by 3, and on this side you are left with 3.14 times r squared times 12. And on the left side, let's do that. We have 3 times 113.04. 300, well, yeah, that I should have done that in my head, really, I suppose. 339.12. Okay, now we could do this in 2 steps. We could divide both sides by 3.14 and then divide both sides by 12. So you would be taking this number and dividing it by 3.14 and then dividing that result by 12. Or what you can do, like I did in the last problem, and which I'll do again, is you can multiply these two things together. So do 3.14 times 12. And then you don't have to do anything on the other side just yet. That's 37.68. So we'll write this as 37.68 r squared equals 339.12. And then we're going to divide both sides by 37.68. That cancels. I always seem to run out of space by this point, so I'm going to continue up here. We have r squared on the right side, and on the left side, we have to do 339.12 divided by 37.68 is 9. Okay, so it's giving us some nice, easy numbers here. Okay, so remember what this is telling us. This is saying that the radius squared is equal to 9. It's not saying that the radius is equal to 9. So we have to ask ourselves, what number when we square it, in other words, what number when we multiply it by itself gives us 9? How about 4? Is 4 times 4 equal to 9? No. Is 2 times 2 equal to 9? No. You know the answer. The answer is 3. 3 times 3 is equal to 9. So if r squared is equal to 9, then r itself is equal to 3. And another way that we could have done that is by taking the square root of both sides. And the square root of 9 means the number that when multiplied with itself, gives you an answer of 9. And that is 3. And you can do that in the calculator just by typing in a 9 and then hitting this button over here. And that gives you 3. Actually, there would be 2 answers. Can you think of what the other answer is? The other answer is -3. So -3 times -3 is also equal to 9. But we don't want to bother with negatives right now. The radius is not -3 inches. That doesn't really make sense. The radius is just a regular positive 3 inches. So that's going to be our answer. Type that in. Okay, and this question looks to be the same as another question that we did. You just have to remember that if IXL is giving you a dotted line going all the way across, then that means that this number here is the diameter, not the radius. If I want to find the radius, I would have to take this number and divide it by 2. So if all the way across is 28, then the radius would be 14, because 28 divided by 2 equals 14. So that's where that 14 came from. And then the rest of it is the same. You plug in 14 for the radius, not 28. Okay, let's jump ahead to the next level. Okay, so this is another problem where it's giving us the volume and it's asking us for the radius. We just did 2 of those, so I'm going to skip to, I can't skip to the next level. Excuse me. Okay, so it looks like we found every type of problem that IXL is giving us, except I'm not sure. Maybe it'll give me a problem where it asks us for the height. The height would be basically the same as finding the radius. You start with the volume formula, you plug in the volume and the radius, and then you solve for the height. But it didn't give us any questions like that. I don't know if there are questions like that in this skill, but it's very similar to doing the radius, so I'm not even going to continue with this problem here. I'm just going to end the video there. Hope that was helpful. Reach out to me if you have any questions, and have a great day.